Circadian rhythm and stages of sleep are interconnected. And during wakefulness, that is during the day, the body's rhythm is promoting alertness. As towards the evening, where the drowsiness sets in and the sleep pattern begins, we have two phases of sleep, non-REM sleep and REM sleep. Non-REM sleep has three phases, N1, N2, and N3. N1 is the lightest phase, that is the stage 1. N2, decrease in body temperature and brain activity is stable, is a transitional phase between wakefulness and deeper sleep. And then is the N3 sleep, that is the deepest stage, which has body repair, the tissue regrowing, strengthens the immune system. The non-REM sleep is followed by the REM sleep. REM sleep shows increased brain activity, vivid dreaming, and emotional processing. Circadian plays a role in timing of REM sleep onset and duration. REM sleep thus follows circadian rhythm. During a typical night's sleep, first REM period occurs at about 90 minutes after falling asleep. And as the night progresses, the duration of REM increases, meaning it is more prevalent during the later half of the night. Now, this can be affected by what is your chronotype, like if you are a morning person or a night owl. Morning types will have earlier REM, whereas evening times will experience REM sleeps later in the sleep cycle. Point to note here is the light exposure, especially in the evening. The exposure to the artificial blue lights from the screen can suppress melatonin production, the hormone which promotes sleep and regulates REM sleep. So avoiding blue light from the screen is advisable in the night towards the sleep time. The circadian sleep has a homeostatic control. Homeostasis is the body's tendency to maintain balance in the physiological function. Homeostatic control of the REM sleep is by REM rebound. That is, if you are deprived of REM sleep on the previous night, body will compensate it by increasing REM sleep time during subsequent nights. This is also called as REM catch-up. REM pressure. This is the accumulation of need for REM sleep. This happens if we do not follow the REM cycle or the circadian properly. So REM pressure is one of the homeostatic mechanism that ensures that we have enough REM sleep. Dreaming and memory consolidation. REM is associated with dreams, emotions, and memory. And thus, homeostatic control of REM ensures that the brain has enough opportunities to process emotions and to consolidate memories. Circadian rhythms in animals for their adaptation and survival. These rhythms are deeply intertwined with animals' physiology, behavior, and ecology, allowing them to adapt and thrive in diverse environments. Sleep-wake cycles. Circadian rhythms influence the sleep-wake patterns of animals. Many animals, even humans, show diurnal or nocturnal behavior based on their internal clocks. Nocturnal animals have evolved to be most active during night to avoid predators and utilize the cover of darkness for their activities. Whereas diurnal animals capitalizes on the daylight for foraging, mating, and other behaviors. Some animals are crepuscular, which are more active during dawn and dusk, which allows them to avoid extreme conditions of day and night. Foraging and feeding behavior. Circadian rhythm is closely linked to the animal's foraging and feeding behavior. Many animals have developed behavior that align with the availability of food sources during specific times of the day. This synchronization optimizes their chances of finding and consuming prey, like Species of insects, birds, and mammals are more efficient at foraging during specific periods of the day when the food sources are abundant and accessible. Predator and prey interaction. Circadian rhythms influence the timing of predator-prey interaction. Some predators have evolved to hunt during the times when the prey are most vulnerable, while prey species have adapted behavior to minimize their exposure to potential predators. This dance of predator-prey interaction influences the rhythms of both the parties, maintaining the ecological balance. Reproductive strategies. Circadian rhythms may play a role in timing of reproductive behavior. Like in many bird species, singing at specific times of the day serves as a way to attract mates and establish territories. In some cases, the timing of this behavior is governed by circadian clock to maximize their effectiveness. Similarly, timing for mating, egg laying, and other reproductive activities are also influenced by circadian rhythms. Migration and navigation. Circadian rhythms are essential for animals that engage in long distance migration. These rhythms help animals to maintain a sense of time and direction, allowing them to navigate across vast distance. Many migratory species, they depend on the cues such as position of sun, star, earth's magnetic field and adjust their internal clock so that they successfully reach the destination. Social behavior and communication. Circadian rhythms impact social behavior and communication among animals through courtship rituals, displays, and other social interactions. These behaviors are synchronized with circadian rhythm, allowing effective communication and mate selection. And thus, circadian rhythms are a universal feature of animal life. They influence wide range of physiological and behavioral processes, which is critical for their survival and adaptations.